right. Taking a look at number 8 and 9, you guys were looking to see if we can prove SAS. And in number 8, when I started looking at it, I was like, okay, we can call XZ congruent to XZ. That's going to give us a pair of sides right there by reflexive. And then I have another pair of sides here with these congruent, but they say specifically to use SAS. And if I was going to use SAS, the included angles aren't W and Y. The included angles would have to be the X and the Z, and we don't know those are congruent. So in this one, can we do it? No. And Y, these guys would be the included angles, and they're not in between. No, these guys are not the included angles. That's what we want to say. Angle W and angle Y, it's no help knowing that they're congruent because they're not the included angles. Now for SAS on number 9, and on your line, or on your copy of the review, what I need you guys to do is recognize these markings here mean parallel. And if these two lines are parallel to each other, this is where we might have some luck, maybe getting to an SAS. We'll see. If those two lines are parallel to each other and they're cut by a transversal, ooh, I don't know if that's helping us either. Two lines that are parallel and cut by a transversal have alternate interior angles that are congruent, but I don't think that's helping us. Oh yeah, it is. Yeah, for sure. For sure. So this is our side pair that's congruent. We've got this side and this side. Yeah, right here at X, up here, that WXZ is going to be congruent to YZX because those guys are alternate interior angles. So you had to take this drawing and deal with the parallel lines. Those markings meant that the lines were parallel. And then when I highlighted the diagonal through this is going to be considered like our T or our transversal. And as soon as I look at it that way, as this is a transversal through two parallel lines, I've got alternate interior angles that are congruent to each other. And so what we have to do in this one, we don't even have a given stated for us, but we need to get to explaining that the two triangles are congruent. So I'm going to go to my piece-lined paper for room for statements and reasons. This is a complete proof that you could be sure of seeing something like this on your test. In the case of this problem, the first thing that I'm going to do is talk about the stuff that was given to us. And what was given to us was that segment WZ, it was given to us because it was marked, was parallel to segment XY. That was marked for us. And knowing that led me to, so that was the first thing I tackled. I said, all right, those things were marked parallel lines. And I drew them in, I cut the transversal, and I came up with, what was my angles? WXZ. Angle WXZ is congruent to angle YZX. YZX. And that is the definition of alternate interior angles. When two lines are parallel and cut by a transversal, alternate interior angles are congruent to each other. That justification came up in one of our that group practice stuff you guys did too. You'll look at your group problems together tomorrow. I've got that, but I don't. That big paper we were gonna do. Yeah. Number 3, I'm going to state the next thing that was given to us. We had markings. I went over them. WX was marked congruent to ZY. WX was marked congruent to ZY. And that was given. And, you know, when I say given, it's in this case, they didn't state it for us as a sentence. I say it's given because they were marked for me. These proofs have to be in SAS. So my included angle is right here. It came in first because I talked about that first. This is one of my pairs of sides. And then this angle is included though, so there's no problem about the SAS. It's going to be out of order here. But then I have to pick up my other pair of congruent sides, and I put 2 markings on that diagonal. We've got to just talk about how ZX is congruent to ZX. Just point out that side is congruent to itself. What property lets us say it is what it is?
Reflexive.
So once we've got that in there, we're proving we've got our side, included angle, and side. And so I've done everything I needed to do to get at WXZ is congruent to YZX. And this is an SAS. And it was out of order here, but notice I put included angle. Since it was included, it doesn't matter, it wasn't in order here. I know it's included, so this fits. So there is not a justification that is SSA or ASS, but it's written in that order here. It's the angle that's included, so there's no problem here. Nice try. All right. Number 10, 11, and 12. I think we can do these right on here. The first one, I'm going to go with this one I'm going to use colored pencils on this one. So the first thing is QP is congruent to QR. And so that's putting us just on this triangle here on the far left. That's isosceles. I just kind of shaded that one in red and then if I know that those 2 angles are congruent, that means by the base angles theorem that angle P and angle R are congruent to each other. And they didn't ask for theorems here. Watch for that on your test. That's base angles theorem. When we start with sides and we go to angles, it's the base angles theorem. It's the converse of the base angles when I start with angles. So actually, here you go. Here's your theorems for each of these. If I start with angles, it's the converse. I'm going to pick up another colored pencil to do the next one. Looking at what they're giving me for this next one, angle TRV. Oh, that's a disaster. Whoopsie, sorry video. Angle TRV, so they're talking over here, is congruent to TVR. They're talking over here. I've got those in green. So it's this triangle they're talking about by the base angles theorem. RT and TV are congruent to each other. RT and TV. I'm over here. Make sure segment notation goes over the top. RT and TV. Grab myself another color, number 12. They got me now on this triangle with RQRS. And then that is going to force angles Q and S to be congruent to each other. And let me guess, the last triangle they use is going to be the one in my drawing that's not shaded yet. So this one, yep, sure enough, they're taking us to SRV. This angle right here is congruent to SVR, this angle right here. So I'm focused only on this triangle. And then that's going to make side RS congruent to side SV. RS and SV. Now, last but not least for today are number 14. Couple things going on in here. I see on the right-hand side that I've got markings for a equal angular triangle. So that tells me that these angles inside of this on the right in number 14 are all 60 degrees. Down here on this last one, let me zoom in for class. So that tells me that all these angles are 60 degrees. This has got the figure out. So this left-hand one is isosceles. I can tell by the base angles. And so if that's isosceles and this side's 26, I know this side's going to be 26. That means all the sides of this is going to be 26, and I just set a problem up for myself. So I can get at my y because all the sides of this equilateral triangle match up with the isosceles lengths on this one on the left. So 5y plus 1 is 26. When I take away 1 from both sides, 5y is 25. When I divide by 5, y is 5, 25 divided by 5. Ran into that as I was going around the circle or going around the equilateral triangle with this 26 degrees. And then we've seen this throughout the chapter, and I'm not sure everybody was looking for it initially, but hopefully now you are. If I take a look at what's going on here with this 8x sitting next to that 60-degree angle, those two guys are a linear pair. So 8x plus 60 is 180. They sit on a line. Those two are a linear pair, so 8x plus 60 equals 180. And when I take away 60 from both sides, I get 120. The 60 is, that's an equiangular triangle next to it. 8x equals 120. I don't know what that is. Can somebody divide 120 by 8? All right, I'm going to stop. Y'all can figure out what that is.